Hello everyone, we are from Group 16. Today we will present to you about microorganisms in yogurt production. Let's start it! Yeah!
The fermentation of milk by lactic acid bacteria, mainly Streptococcus thermophilus and Lactobacillus. These bacteria work together to convert lactose in lactic acid, which is level the pH of the milk, prevent spoilage, and give yogurt its tangy taste and creamy texture. Different strains of these bacteria can carry different flavor and texture.
Besides these main bacteria, yogurt may also contain probiotics such as bifidobacteria. Probiotics are beneficial microorganisms that help support the digestion, boost the immune system, and improve the overall quality and shelf life of yogurt.
Creativity and visual aids are helpful for explaining this scientific process. Diagram and animation can show how the bacteria interact during fermentation and how probiotic works in the guts. This visual make the concept easier to understand.
Slide number 1. Hormone fermentative pathway. First, we have the hormonative pathway, which is the main pathway in yogurt fermentation. In this process, lactose is broken down into glucose and then converted into pyruvate, and finally lactic acid. The key enzymes involved are beta-galactosidase, which breaks lactose, and lactate dehydrogenase, which converts pyruvate into lactic acid. The main product is lactic acid, and this is what gives yogurt its tangy flavor and thick texture. Slide number 2, cross-feeding interaction. Next, we have the cross-feeding interaction between Streptococcus thermophilus and Lactobacillus bulgaricus. As the thermophilus produce formate which helps stimulate the growth of L. bulgaricus, on the other hand, L. bulgaricus breaks down milk proteins and release peptides, which then support the growth of S. thermophilus. So both bacteria help each other, and this makes the fermentation faster and improve the yogurt quality.
Slide number 3, heterofermentative pathway. Some probiotic bacteria use a different pathway called the heterofermentative pathway. This pathway produces lactic acid but also acetic acid, ethanol, and carbon dioxide. These extra products add more complex flavor and sometimes like carbonation in other fermented foods, though not usually in yogurt.
We are going to dive into a case study that highlights the incredible power of common dairy cultures. A critical study published by the Journal of Dairy Science in 2020 shed light on the mechanics of yogurt enhancement. Specifically, the research demonstrated that two key players, Streptococcus thermophilus and Lactobacillus bulgaricus, are instrumental in improving yogurt quality. The way they achieve this enhancement is through a well-known process, the production of lactic acid. While the co-finding we are referencing are from 2020 journal publication, it's worth noting the foundational work on this topic has been around for some time, with early related research dating back to November 2003. Understanding this microbiome mechanism The production of lactic acid by these two bacteria is fundamental to how we optimize and improve fermented dairy products. Let's now look at the specific commercial application of this finding. Before we discuss the final product, let's introduce the two essential players behind all quality yogurt, the microorganisms involved. First, we have Streptococcus thermophilus, often abbreviated as S. thermophilus. This organism is the early starter in the process. Next, we have Lactobacillus delbrueckii bulgaricus or L. bulgaricus. This organism is often characterized by its stronger proteolytic activity. This means L. bulgaricus breaks down main proteins into smaller, more easily used peptides and amino acids, specifically mentioning valine and glycine. And these broken down components are essential for the growth of its partner S. thermophilus. So, what we are seeing here is a perfect symbiotic relationship. They depend on each other for optimal growth. One provides the starter, the other provides the food, leading to a much faster and more complete fermentation.
First, let's look at the problem and situation faced in yogurt making. Number 1, limited growth in milk. Lactic acid bacteria or LAB have slow growth in milk because milk doesn't have enough nutrients for them. Number 2, need for rapid growth. In yogurt factories, we need this bacteria to grow fast to make yogurt quickly and get strong acidity. Number 3, strain interaction variability. The interaction between Streptococcus thermophilus and Lactobacillus bulgaricus can change depending on the strain, milk type, and temperature. Sometimes the interaction is good, but sometimes it can reduce efficiency. Alright, research result now. Let's look at the research result. Number 1, key microorganism and synagrips. The two main bacteria, Streptococcus thermophilus and Lactobacillus bulgaricus, work together. Streptococcus grow first and produce formic acid and carbon dioxide that help Lactobacillus grow. In return, Lactobacillus release amino acid that helps Streptococcus. Number 2, yogurt quality formation. These microorganisms are very important because the effect and the texture, taste, and acidity of the yogurt. Their balance decide how smooth and sour the yogurt will be. Number 3, market and function traits. According to recent studies, especially from Focus 2020, yogurt which beneficial microorganism is becoming more popular because it supports good healthy and digestion. That's all for the research and the result.
Include lactic acid bacteria such as Streptococcus thermophilus and Lactobacillus bulgaricus play a vital role in yogurt production. They work through the homofermentative path to convert lactose into lactic acid, which is give yogurt its characteristic tangy flavor and creamy texture. In addition, probiotic strains like bifidobacteria enhance the nutrition value of yogurt and contribute to the development of new flavor and texture via the heterofermentative path.
Finally, the principle of yogurt fermentation extends beyond the food industry. These bacteria are applied in agriculture, wastewater treatment, and aquaculture, demonstrating their potential for sustainable and innovative solutions across different sectors.
This is the reference and that's all from my group.
That's all from us. Thank you. Bye.